Hi everyone. Let's continue with another data set. Now we have exposure data set. Since I already practiced, I already did this one. I have done the programming already. So I just need to explain you guys how we do exposure data set. It's a similar pattern how we did in a DM data set. So let's go continue with the exposure data sets. So we have a header part here. The file name is exposure ex, and the author is my name is Ali, and there is a project study ID which I just keep it as missing right now. And for exposure we need two raw datasets. So one is a demog.raw and another one is exposure raw. Okay, so the output dataset should be exposure dataset, SDTM EX dataset. Then we have a modification history, first name and last name. Okay, so this is a similar pattern how we did it with the DM datasets. Let's save this one as the EX program. EX. So since we have the previous raw data sets, previous data sets, so we need to remove, we need to clear this console as well. Okay, so let's continue. Let's finish remove that part first. Control Enter. So all the data sets are, the previous one is gone, and we have some console information. So that one also we can put just Control L. It will go. So now let's continue with this one. So we'll be having some packages which we are going to import. Basically, we already have these packages installed in our studio. So if someone doesn't have this packages, you should have to be installed first. Then only you can read these libraries. Okay. So Haven, Tidyverse, Deployer, Hybridate, Admiral, and the string. So I have explained all these 5 of them, Admiral up to Admiral last class on DM datasets, and the stringer part is, so basically it works for the character functions. Okay, so let's set the working directory. Need to change working directory back to our clinical. Copy this part, paste it. Remember, you should have 2 slashes to get the working directories. So the current working directory you have here is the R clinical resource. So now we have to import our raw data sets. So this is raw data set file is also not correct. So I need to change, I need to update. Let's go here again. So we have documentations here, we have a raw data set here. Copy this one. So remember, these are the SAS data sets, so we need to import into the R data set to convert. So we have to convert into the R program. Let's put slashes, backward slashes. And for SDTM, because we need to access the DM dataset, right? Because we need to do here study day calculations. So for that one, we need to go back to the yesterday DM dataset, what we saved. For example, here, all right, we need that information. That is a dataset we have saved with the similar things. 2 slashes, and here we have to keep 2 slashes again because we are going to inside the data new folder, right? Folder raw dataset folder. That's on this. Control Enter. So Control SGM Enter. These two are successfully entered. So let's read the exposure run. So as per the specification, so these are the variables we have to derive. Okay. The majority of them permissible variables. So first and foremost, we need to filter out the required variables. So here and here. Can check for the required variables first. Okay, so these are we have to hit. Then we go to the expected variables. We have to create this as well, and then we have to go to the permissible variables. That okay, the permissible variables basically, if if the data was given inside the raw data set, you have to map it. Otherwise, it is not required for the final data set. Okay? These are just permissible way. Okay, let's continue with this one. Yeah. Now we're gonna import this DM dataset because we have SDTM path where we have a DM dataset, right? So exposure. Let's run the first exposure raw dataset. So we have exposure raw dataset has a 92 observations. Okay, so almost like 92 entries, and it has 13 total columns. Total 13 columns have this raw data. Then we have a DM dataset. Okay. Here is a small correction because we are reading the SAS7 BDAT, which we're not reading it because this is RDS file. The path we have given is DTM. This RDS file is not SAS7 BDAT, that's why it's not reading it. So I'm having error here. So now I've just checked it. I have changed to RDS, read.rds instead of read SAS, because this is RDS R dataset. Okay, so I'm using this path SDTM and the DM RDS. Let's run this one. So we have 48 observations, 25 variables here. Open this one, you'll be having the final data set of DM we done yesterday, right? Thereafter, we're gonna continue with the exposure. So here we are reading the exposure raw data set, which we are using the assignment operator, arrow mark. This is the pipe symbol for continuation, and this is a mutate functions. It works. The mutate is working coming from the. Okay, so the mutate function is coming from the deployer package. So basically it works to add new columns, or if you want to modify the new existing columns, so you have to use this function bit. Okay, so make sure you understand the parenthesis. The parenthesis starts from here, which has to be end here. For example, you can see. So when you see this parenthesis here, when you click, so you can see able to see that highlighted part here after the mutate. So this is basically the mutate function works up to here, right? In order to create a new variable, so we have to use this mutate functions, and in that you have to use all your the variables should be created. Okay, so make sure the parenthesis should be very clearly right. For example, this parenthesis is end up to here for the study. So this parenthesis is end up to here. So this string only is it finish here, right? So here as well. So here they have two parentheses, right? So one is for those and one for the string. So make sure the parenthesis should be correctly mapped. And there is the comma for each individual variables. So you have to be very careful with these indentations. Otherwise, it will be a disaster. I mean, not disaster. Clarifying word. Yeah, it will give an error. It won't read properly. Okay. So, and one more thing, so the R is a more case sensitive, so we have to be careful if you are giving the capital letters. Okay, so you should have to give the capital letters if you're giving because the SAS is a case sensitive. It's not is case insensitive. Sorry. So because in SAS you can use either capitals or prop case or small letters. So, but here it don't work like that. It doesn't work like that because why I'm saying so, because if you're using study in small letters here, like for example in the DM data set, study ID, sorry, not exposure data set, see study is giving in the capital letters, right? So if you write here study in small letters, okay, so anyway it's giving that automatically, it's giving this one. But if you use the small letters, it won't work. Just make sure you understand that part. The study ID is here is we just mapping directly to the study. Then we have the domain is exposure EX for the specification. The domain is EX. So this function variable. So dm is ex here. Then we have subject ID. So the trim wx function is works similar like strip function. So we're mapping to the subject ID as per this. Why I map, but anyway, so we keep it as subject ID because this is given in the raw data set. Oh, okay, perhaps it has given the subject IDs in the raw data set. Yeah, subject ID is given, so that's why I'm mapped for that subject ID. Then site ID, site, map to the site function. Okay. Then we go continue with the unique subject ID. So this is a paste function. The paste function is basically you just works like a print function in the Python language, finding that all these three as concatenate function catex. So it works similar like that. So 0. Then we have exposure treatment, the TRT. So we directly map to the TRT. This one, exTRT is to the set to TRT variable from the raw dot exposure. Then we continue with this ex those. So here we are converting to the numeric format. As dot character, as dot numeric is basically you're converting to character to numeric and numeric to character. So this function will works like that. And then we have a string substr function. So this structure substr function basically to use it to extract the strings from those variables. So we need 1 and 2 because ex, let's check the ex. Here ex those quantity part if those. So we need to get a quantity part those. So in the those we have quantity part 10 mg. We need to get ex those. So for the first one we need to get 2 parts. Okay, here's the quantity part. Basically it's not mg, it's not unit, sorry, correction here. We are extracting the first 2. Okay, these 2 are extract. So this is a quantity part. I confused. So this is quantity part if those. Then we have unit part for ex these things. Okay, now we understand. So we are taking the first position and the 2 characters. Okay, characters using the structure sub. Works similar like substr function. And we have ex those text. So this one we have ex those text. I think this is so this is docent. And you can also cross check with your TRF part as well. Because okay, assign the pattern directly given. Ex though. So this is annotated CRF. Mention anywhere. Directly giving those. Okay, so here we have those and text in the text format of drug oxybutynin. Then we have the dose exposure unit ex dose. Also permissible variable. Unit part of POE variable. E variable. I put those here. The lowercase because it is in the control terminology. in ng in the small letters, small case, lower case. That's why we have to use the structure to lower those three. Substitute those. Then after we have ex those form. So ex those form. Also those. Let's check. This is in the capital letter. The submission part in the capital letter. Structure like string to uppercase W. Those the tablet forms, like what are the sources form for this particular tablet form. Then we have frequency, how much frequency we are giving. That is also check. To once here. Also in the capital letters, uppercase. We're keeping to the frequency times the drug has given. Then we have the route of administration. Take this route of administration. Set to oral as per the control terminal. This part. This is in capital letters. This is uppercase, the root. Have a exposure fast. Here we have exposure fast is around set to y because it was fasting study as per the so we are this is we are trying to give it an uppercase because as per the control given to the uppercase only one letter. If it's not available. We have to give only. Let's check fasting condition. Yes, so we as y we need to get for first position and first letter. So this is the substitute function uppercase for the fast variables. Just stripping as I don't know why you need to use this. Then epoch, the treatment phase. Epoch is the treatment phase, directly mapped to epoch as a treatment. For the data collected, we need to assign as per the CT. Okay, so far we have completed this ones. So let's check with other variables. We have, let me run this one first. Like there is no error. All the information. Okay, so here we have exposure 1 data set. So all the data set required, all the variables required, we got it. Okay, so then we continue with some other variables. So here we are taking from this ex1 data set, and then we are creating some more variables by using the method functions, and there is a pipe symbol here. Make sure it's pipe. For the pipe you can use control So shift plus control plus M in Windows. If you have in Macs, you can use command in. So you can use this one to get pipe symbol, example, like that. So here we have a DSDTN format. So we need to change because the DSDTN, this is in the format of month, date, and year format. So we need to change first with the month, date, year format. Okay, because it has in year format. Basically, we're trying to change the numeric format as well. Okay, so then we start with exposure start date here. The exposure start date of treatment, start date and time of the treatment is concatenated with the date and time. So if you go to the control terminal, DDT. See? So in the EX, we have two variables from the raw data set. So dosing time, dosing date. Okay, so we are considering this one for the start dates. So here we have considering the dose N and dose DTM. Both are in the numeric format here. So we are changing to the character format because as per the specification, it is in the character format. So here, as per the control terminology, we have a character format. So that's the reason we are for the numeric format, we need to convert it into the character format. So here we have, sorry, so there is a separation we call T here as a character. So there's DTN and T as a DTM. So then this is in the character format because the C represents the character. So we have to have a numeric because we need to do some steady date exposure date calculations. So here for that reason we have changing to the as.date format. So because as.date is basically it works to represent if you have any the values that is represented into the date format. It indicates, so because those DTN is giving us it's a date format, but it's giving us a value. So that's the reason we have to use as.date for changing to date format. So so we have to use a percentage M, percentage D, percentage Y as this is the format we have to use for the date. Okay, so we're changing to character to numeric because this also works for the character to numeric for the numeric format. It works both two functions. Here, let's execute this part. Here we have ex2 successfully executed, and then we have ex2 dataset. Okay, because it is extracting only the date format, not the time formats. That is a function it is used here. So because we are extracting only the date format from the exported data, that is, so it's giving directly to the numeric. So the next one is we need to calculate everyday calculations. Have study day of start treatment and study day of end of treatment. Okay, so these two we have to derive, and for that we need reference start date. So for that we need to get from the DM1 dataset. So this is the DM dataset. That is the why we are inputting here the DM dataset, okay, from the RDS HDTM part. So then once we import the DM part, it works like now we are need to convert into the numeric format by using this another function called convert DTC to DT, the character to numeric format. And we have a pipe symbol, because you see when you have two functions like mutate here and then there is a select also here, so there are two functions. So whenever you change, you are working on the two functions, there is a the pipe symbol will be there to combine both together. So now we have three variables to selecting from here. DM data one, have a three variables. Then we once we get, we are sorting these two, DM1 and AX2. We're going to merge with these two. Check this. Yes, it seems like I have some warning message here. Basically, it is saying that the format is contains incorrect date and time, so maybe incorrectly imputed on this one. So let's check this DM1 first. Here we have the date here, and we have here is time with the format is kind of different. Basically, because it has convert DTC, I was thinking this is the one. Maybe let's change into date right here. Not find the function. Okay, sorry. So you need to change. Make sure you, as I mentioned, this is case sensitive. Is in the capital letters. So we don't get any problem here. We got all the data. Okay, there is no warning message. Okay, let's sort this order, DM1 and exposure 2. Then we combine this DM1 exposure 2 by using the unique subject ID as an inner join. Okay, combine it together. Okay, so then we do this exposure study date. If else, because is.na is if you have any missing values, not equal if there is no missing values, less than or equal to, if there is no missing value for RFS, less than, sorry, if there is no missing values for the RF reference start date, then we have to give as exposure start date minus reference start date, or else exposure start date minus reference start date plus 1. That is for the start day, study day start calculation for the treatment. Okay, so just be careful, because we are giving the FLs, because if it is this case, we'll give it as this one, otherwise this one. All right, and the not, there is a not symbol here. There is no missing values. .na is basically represent for the missing values. So if there is no missing values, and also in the reference start date, if there is no missing values, we have to give this formula. If there is a missing values, we have to give, I mean, if this one greater than exposure start date is greater than reference start date, then we have to give add plus 1. Then we do the similar for the exposure NY, because it is the same thing. We just taking from the exposure end date to the reference the subject start date. Okay, so then we calculate the exposure durations, so subtracting from the exposure end date minus exposure start date plus 1. Then we have to calculate exposure duration in this format by adding the P as per the control as per the implementation guidelines. Then we use group by unique subject ID because we are calculating based on the subject ID, like unique subject ID. So that is why we get group by function. Then we have to do allot the exposure sequence. So this is one of the way we add the exposure sequence. So one is to n hyphen. So this one is contain the sequence number like 1, creating the exposure like exposures for each individual record. Okay, so then we continue with other. So we are selecting. Basically, we have completed all these variables. So the remaining variables we don't need it, because there is no data available for those ones. That's the reason I don't write this part. See here, these variables we don't need to create, because we don't have that information here. If there is information, because this is only 13 variables, right? If there is information here, you can map it with them. If they don't have, we just we just ignore them because this is not required. These are permissible variables. Take all of them. So uh, we get the label. We do the similar like how we did in the DM dataset. So we did with having the seek letters in the front, and we combine all together, all the variables, whatever they required, to get from here in the specifications. So then we have to do with the hmiss. We do the similar like we are updating this variable with the labels that we have here. Okay, so once we verified this exposure 3, so we run this one. We have exposure duration here. Let me check the exposure 3 data set. It has a 92 observations and 37 variables. We have 92.7 entries. We have a study day calculation here, exposure start date and exposure end date, and we have a duration part here. Then after we also have exposure sequence 1, 2, 3, right? Then we apply the labels similar like how we did with the ResLab. Then we do using the installation like library h miscellaneous with up data. So make sure this should be in the capital letters. Just one message. So there's no error here. Let's check the ex, the final data set. So we got all the informations. We have the labels are here. Then all the required variables we got. So let's save this as a database RDS datasets. So check that. Here we have it. I'm gonna save it here inside the DM dataset. All right, thank you for listening. We'll continue with other datasets tomorrow. Thank you.